Let's see.
All
right, so it's
Let me
loading.
check the spreadsheet. Hold on, because I don't have access to do any of that. Just a second.
Let's see. All right, we're live.
All right. So, hi everyone. If you're in the Zoom session, which I only see Donato, go ahead and put what club you're from and what class you are in Pathfinders, just so I can get to know you guys a little. Awesome. Well, welcome, Donato. All right, and we'll get started probably in 2 or 3 minutes, just so anyone joining the Zoom can make it in.
Hey, Casey.
Yeah.
You might have to let me know on this as we talk to the participants, and they might chat with you. I'm a few feet away from the computer.
Okay,
So
yeah.
if I need to come and do a close-up, just feel free to interrupt me and let me do it.
I can do that.
Tell me to do that, and I'll do a close-up. So what is going out onto the YouTube channel right now? I didn't realize we had that going.
You guys are already live, so go ahead and start so that people can watch you on that side, even if no one's in here.
Okay, perfect. Well, welcome to Model Rocketry. I'm Casey Ramey from the Umatilla Pathfinder Club, and I will be teaching this with my father, Rodney Ramey, who is in North Carolina. Dad, is there anything you want to add?
Nothing else I need to add right now, except I was active in a Pathfinder club when you guys were smaller, and this is one of the shirts from that. But that's it. We're going to talk about model rocketry and what these things can teach us about God.
All right, so just an overview of the order of events for today. We're going to start with a spiritual application, or devotional thought that my dad will give. I have a presentation that goes through the bookwork part of the honor, and that matches the worksheet, which is available through the Varsity Camporee website. We'll also talk about the safety code, and then Dad will walk you through a step-by-step of how to assemble your rocket. And we'll also give you a chance to view a rocket launch. And for anyone in the Zoom, we'll have a Q&A at the end. And we should end probably right around 3. All right, so Dad, will you go ahead and open us up with prayer?
Sure. Heavenly Father, as we begin this, Lord, there's a whole lot of object lessons and things that we can learn from model rockets. I mean, it's not something that's not only fun, but it's also something that can teach us about you and about the way you've created things. And so, Lord, please bless us in this meeting today. And Lord, may it not be just a time of learning some new craft or skill, but a time where we can also learn about you. Amen. I guess this is me. Keep talking.
Yep, it's your turn.
Okay. All right. So as I was looking at the rockets and everything, I thought, what kind of spiritual application is there from these rockets? And so I'm going to share with you just a couple of small things here. It won't take me long, but the reality is we could probably go on quite a long time just talking about the spiritual application of model rockets. The one that I think of the most, and Casey and I were kind of talking about this earlier, I don't think she realizes it, but she had asked me about getting one of the Pathfinder shirts from Carolina. And I have a Pathfinder shirt that is Carolina blue. In other words, a light blue. The colors of our teams up here, much like in Florida, you have the Florida Gators with the orange and blue, and of course, FSU with their red and gold, or garnet and gold, pardon me, not red, garnet and gold. Have to say that correctly. But here's a spiritual application that you can look at from it. Do you remember the song? Most Pathfinders will, or at least most Pathfinders my age will remember the song. I'm not too sure how many newer the Pathfinders will know this song, but I'm sure a few of you will. And that is, "Humble me so I can do thy will." And it says, oh, you can't get to heaven on roller skates because you'll roll right past those pearly gates. Humble me so that I can do your will. Basically saying, look, you can't get to heaven any other way than through Jesus. Well, one of the parts to that song that nobody knows except for people that are from North and South Carolina is you can't get to heaven in a red canoe because God's favorite color is Carolina blue. Humble me so I can do thy will. Now, of course, we have fun around the campfire singing those songs, but there's a lot of truth in that. We cannot get to heaven any other way except through Christ. I mean, we build these rockets. We built rocket ships. We put people into space. We're planning to go to Mars. Yet at the same time, can we get to heaven that way? And of course, the answer is an absolute no. There's only one way to heaven, and that's through Jesus Christ. And so I think of that when I'm looking at these rockets, and think of how other things that it can teach me. In fact, through the presentation, I'll probably give you a couple of more spiritual lessons as we go on. But just remember, there is only one way to heaven, and that is through Jesus Christ. And he's not powered by a rocket, by anything man-made. It is through his power and his grace that we get there. Casey? You're muted.
I'm muted.
Yeah, there you are.
Okay, so do you see the whole presentation screen or just the?
I see the whole one.
Okay, then we're going to do this the other way. All right, so the first requirement, or one of the requirements for the honor, is to know the different parts of the honor. And this is a cutaway view of a model rocket. Let's see if I can get the laser pointer. Maybe. Okay, so I'm going to start the nose cone. The nose cone is going to be typically made out of plastic if you buy a kit. However, my father will show you how to make it out of cardstock. And that will be removable because the nose cone is attached to the rocket. Well, for one, it sits in the cardboard tube, but it's also attached with an elastic shock cord. And that way you don't lose your nose cone when it's ejected, which we'll get into later. And then we have our parachute, and that's attached to some different parachute lines, and that is going to help our rocket fall slowly back to the ground and not hurt anyone. Up next, we have some launch slugs, which are basically straw-like pieces that the wire of the launch pad will go through. And that just makes sure that our rocket shoots straight up where we want it to. Then we have recovery wadding, which is out of a flame-proof material of some sort. It makes sure that our engine, when it ignites, does not melt or otherwise damage the parachute, and all the parts of the recovery system. And then we have an engine mount, which is basically a secure glove for our removable solid rocket engine to go into, which we'll get into a little bit more later. We also have our fins, which stabilize the rocket in the air, and of course, the body tube. And if you are looking at the worksheet, you should now have the answers to number 1. All right, we're going to skip down to number 3 and talk about the flight of the model rocket. So for your worksheet, you are going to be drawing the different rockets in the different stages of flight. So first we have our launch, which is where the igniter from the launch system lights the engine. The first part of flight is the powered ascent, where the rocket is being propelled by the engine. And then we have coasting flight. At this point, the engine has stopped firing, is not producing thrust anymore, and the rocket is now coasting. The highest point, right before the rocket starts to fall back down, is the point of apogee. And so I'm just going to put a little star for the point of apogee. All right, then we have our ejection charge, which is where a whole lot of pressure from in the engine shoots the nose cone off the rocket and shoots the parachute out, so that way the rocket can slowly fall back down to Earth, and hopefully you will be able to recover your rocket if it has not landed in a tree. When I did this, I did this at Camp Kalakwa when I was in 6th grade, and my rocket landed in a tree and was there for several years, probably until the first hurricane that came through Kalakwa.
It may still be there.
Yeah. All right, so now for 2 and 4, you're supposed to define the different recovery systems. So the first thing I want to let you know is that the only rocket recovery system that we're allowed to do for this honor is the parachute or streamer recovery. And that's when the nose cone is ejected off the rocket, the parachutes and streamers deploy, and when that happens, the drag increases, allowing the rocket to float back to Earth. There's also the nose blow recovery, where the nose cone is simply ejected off the rocket, and that ejection causes drag to increase, and the rocket slows and falls back down. Tumble recovery does not have really any official recovery system. When the rocket peaks at the point of apogee, the rocket just tumbles back down to Earth. And this is only done for super lightweight rockets because there is no real control, and a heavy rocket could seriously injure someone. There's also what's called the glide recovery. An airfoil or wing is deployed with the ejection charge. So instead of having a parachute or streamers, we have a wing. And this causes drag to increase, and the rocket is able to glide back down to Earth. For a helicopter recovery, the helicopter blades are also deployed, much like the airfoil or the parachute or streamers, with the ejection charge, and drag increases, and the rocket is able to rotate back to Earth because there are 2 blades that are turning as the rocket falls down. All right, so you've heard me mention an airfoil, and that is a device that creates lift and thrust and drag, and it allows the object that it's connected to move parallel to the airflow. Some examples include an airplane wing, a rocket fin, or a propeller. So if you look at our diagram, we have airflow going above and below. Above the airfoil, it has reduced pressure and high wind speed, and that allows the wing to lift. And below the airfoil, we have a lower speed and increased pressure, and that also helps. That difference in pressure and wind speed creates the lift, and the length of the airfoil creates drag, which is how you're able to use it to slow down the whatever object you're trying to land. You'll often, if you've ever been on a plane, you'll know that as you're about to taxi down the runway, there's little fins that come up on the wings, and those are what create the drag to slow the plane down. All right, so now we get into some physics vocabulary. Fun fact, I have not taken a physics class, but I have picked up on a lot of this from other science classes. So velocity is the measure of distance per unit time for a defined direction. So it's basically like speed and direction, but it's over time. So the formula for that is V equals distance over time. If it's positive, then it's moving forward. If it's negative, then it's moving backwards. Impulse is the total change in momentum, or it's the mass of the object times the change in velocity, and the amount of force applied for a difference of time. So impulse, J, equals delta P, equals mass times delta V, which delta is change. So change in velocity, and that equals F times delta T, which delta T is time. And a stall is anything that causes a sudden reduction in the airfoil's lift forces. So that would be like the fins coming out on the back of the airplane wing. Here's some more physics vocabulary. The center of gravity, or the center of mass, is the exact point where all the mass of an object is perfectly balanced. So here I have, as soon as I can grab it, a pencil. So right here, if I'm trying to balance it on my finger, on one end, it's gonna fall. If I try balancing it on the other end, it's gonna fall. But the center of gravity is that point where the pencil balances perfectly. Like so. And anything, rockets, airplanes, they all have a specific center of gravity. And the gravity of the Earth pulls at 9.81 meters per second squared, just for your information. The center of pressure is the point where all the acting forces are equalized on the object, and where the pivot point is for, that creates motion. So for rockets, it's the point where the rocket turns when flowing through and against the air. So pretend this is my rocket. And the center of pressure is going to be where all the air is going around the rocket and the rocket is stable. All right, so here is a rocket engine. We have our end cap. Well, actually, let me start at the bottom. So we have our casing, which of course you need, and the nozzle. The nozzle is going to be where the ignition parts of the launcher go. And then we have our propellant, and that is the first propellant, for lack of a better word, that pushes the rocket into the air and launches it. Then we have a delay charge that burns out, and by this point, the rocket is no longer being powered by the propellant. That's when we get into that coasting flight. And then, once the delay charge is burned up, we have our ejection charge. And that is what shoots a lot of pressure out through the top of the rocket, or the top of the engine, which releases our recovery system and allows the rocket to land safely. All right, and here is a schematic of a launch pad, a launch system, not a rocket engine. So we have our battery, and this blue line represents a circuit. And so when the battery is powered, it starts sending electrons through the circuit And when the safety is down and the launch part is in place, then we have a complete circuit. Your LED light will be on, showing that there is power flowing through it. And the electrons will go from the battery through following the different blue lines and will connect to our igniter, which then launches the rocket. So, Donato, since you're the only one in the Zoom room, can you post in the chat where some stories of fire are in the Bible? Yep, Moses and the burning bush. That's one I actually had written down. All right. So yeah, that's an example. That is kind of a weird fire because it doesn't really burn out. Like the bush just stays burning. Kind of like those pictures of the Yule logs you'll find, or not pictures, videos of the burning Yule log you'll find where the log just stays the same. All right, Dad, do you have an example?
The first one I thought of was Shadrach, Meshach, and Abednego in the fiery furnace.
Yes, that's another one where burning doesn't work the way it's supposed to.
But I do have one for you that just really does come into mind.
Okay, what's that?
And that is, the Bible says in Peter, he says that at the end, the elements of the earth will burn up. Okay, or actually, I think it says will melt.
Yes, it says will melt.
Now, steel melts at around 5,000 degrees. Now, somebody can correct me and give me an exact number, that's fine. But these big steel girders you have in buildings, you're looking at something around 5,000 degrees to turn it into a puddle. And the Bible says that the elements of the earth will melt. And then in Revelation, we find out that after that happens, God recreates the earth, reassembles all those atoms, all those molecules, and makes it even better than it was before. And we get to witness it. I think that's going to be awesome.
That is going to be awesome. And I had one more. One of my favorite stories, I'm obsessed with horses, I have been since I was a kid, is the story of Elijah being taken up to heaven. He's taken up by a flaming chariot, and chariot implies horses. So flaming horses, which I have tried to draw, it's not easy. But it just astounded me that it's just God and the angels exist in, I want to say, a different world of fire and physics and different things that we can't even imagine. And I, for one,
I call it a dimension.
What?
I call it a different dimension.
Dimension, yep.
The Bible says spiritual realms or heavenly realms is what it says in the Bible.
Yes. All right, so that concludes the presentation part, but we are going to read through the model rocketry code, fire or safety code. All right, so number one, hang on just a second, I'm moving stuff out of my way. There we go. You are agreeing that you only use lightweight non-metal parts for the nose, body, and fins of your rocket.
You mean I can't use that arrowhead so it can stick into the target?
No.
No.
This is not the archery honor.
Oh, sorry. That's next.
Number two, you will only use certified commercially made model rocket motors and will not tamper with these motors or use them for any purposes except those recommended by the manufacturer. So you cannot create your own engines. because it can be very dangerous, and essentially you would be making bombs, which as Pathfinders, that is not something we are doing.
They don't have a bomb making on her?
No,
Oh, man.
we're peaceful. Number 3, for the ignition system, you will only launch your rockets with an official launch system and electrical motor igniters. Your launch system will have a safety interlock in series with the launch switch, and will use a launch switch that returns to the off position when released. Number 4, if your rocket does not launch when you press the button of your electrical launch system, you will remove the launcher's safety interlock or disconnect its battery, and will wait 60 seconds after the last launch attempt before allowing anyone to approach the rocket. Again, you're dealing with some sensitive materials, and it could be very dangerous. Number 5, launch safety. You will use a countdown for launch and will make sure that everyone is paying attention and is a safe distance of at least 15 feet away when you launch rockets with D motors or smaller, and 30 feet away when you launch larger rockets. If you are uncertain about the safety or stability of an untested rocket, you will check the stability before flight and will fly it only after warning spectators and clearing them away to a safe distance. If you've ever watched NASA's launches, you'll notice that all the spectators are several miles away, and they're only viewing the launch through cameras that are set up close or really zoomed in.
That's for safety too. It could blow your eardrums out.
Yes. Number 6, launcher. You will launch your rocket from a launch rod, tower, or rail that is pointed to within 30 degrees of the vertical to ensure that the rocket flies nearly straight up. And you will use a blast deflector to prevent the motor's exhaust from hitting the ground. To prevent accidental eye injury, you will place launchers so that the end of the launch rod is above eye level, or will cap the end of the rod when it is not in use. If you do not use the blast deflector, you will end up with a burned spot in the grass or wherever you're launching from. Your model rocket will not weigh more than 1,500 grams or 53 ounces at liftoff, and will not contain more than 125 grams, 4.4 ounces of propellant, or 320 insec, 71.9 pounds per second of total impulse. If your model rocket weighs more than 1 pound or 453 grams at liftoff, or has more than 4 ounces, 113 grams of propellant, you will check and comply with Federal Aviation Administration regulations before flying.
Now, Casey, can you go back to that just a minute just to explain something?
Yeah.
It says it cannot weigh a certain amount or 53 ounces at more than a certain amount before liftoff. Now, Casey, what is the reason that that it says before liftoff? Do you have a frog riding on your rocket and the frog's jumping off once it gets up so high or something?
No. I'm honestly not sure on that one.
Okay, let me take the heat off of you. It's because of your engine. It's got the propellant in it, and as you burn the propellants, it dissipates into smoke and gases. So now your rocket is actually lighter as it comes back to the Earth than it was when it took off, because you don't have all that fuel.
Got it. So yeah, the rocket you recover will weigh less than the rocket you launch.
Correct.
All right, number 8, flight safety. You will not launch your rocket at targets, into clouds, near airplanes, and you will not put a flammable or explosive payload in your rocket. The payload is only the size of your nose cone, which is very small. So yeah, don't add anything extra to that. That can be dangerous. And number 9, your launch site will be outdoors in an open area at least as large as shown in the accompanying table. I will post a link to that. And in safe weather conditions with the wind speeds no greater than 20 miles per hour. You will ensure that there is no dry grass close to the launch pad. Again, you don't want to start a fire. And that the launch site does not present risks of grass fires. So if you're in a dry area, make sure that your fire safety or the risk of fire is low for that day, as some national parks will post stuff like that. You can also contact whatever park or your county or wherever you're planning to launch to make sure it is a safe day to do so. Number 10, you'll use a recovery system such as a streamer or parachute in your rocket so that it returns safely and undamaged and can be flown again. You'll also only use flame-resistant or fireproof recovery system wadding in your rocket. And for recovery safety, please do not attempt to rescue or recover your rocket from power lines, tall trees, or other dangerous places. When we did this, my dad used to do this with some of his students at a school in Bradenton, Florida, and a couple of the students' rockets remained in the trees for several years.
I think they are probably still there.
Unless a hurricane has come through.
That's true.
All right, so Dad, it is on to you. I am going to stop sharing my screen.
All right. Okay, so let's see. Wow, I've got a lot of stuff here on the table. It looks like a mess. I was looking at my video earlier, which, by the way, I did this on a video. Casey, I believe you posted the link already, or you're going to?
I will.
Okay, and it's about an hour long. I did do another video that I'm in the process of trying to get to upload, but due to size of file and all those concerns, it was kind of difficult for me to get it to upload right away. But it's a shortened version of making the rocket. It's only about 22 minutes long. So anyway, let me go ahead and I'll give you a fairly short version of making the rockets today. If you want to watch the detailed version, just go ahead and go to that link that is 1 hour long, and that will give you the details specifically, and I'll talk about all the ins and outs of the way I do it. By the way, something else to let you know, this is not the only way to build a rocket. There are all kinds of different ways out there, all kinds of different methods. What I'm showing you today either are going to be experimental methods, or it's going to be something that I found to work. For instance, the nose cone, and we'll talk about those a little bit more in a few minutes. I don't have a lathe or anything that I can turn the nose cone on and make a nice cone like that. And so I'm going to show you how to make that out of cardstock, and it still makes a pretty decent cone. But anyway, let's talk about the rockets real fast here. I won't spend too long on them. A general rocket would be one like this one, okay? This one is it's made out of a cardboard tube. The fins, in fact, all my fins you're gonna find are made out of cereal boxes, and the nose cone's out of cardstock. I'm using glue and tape and paint and one little piece of wire and a little bit of plastic on the straws for the launch lugs, and that is it. Okay, so these are all materials that you can find around the house that are easy to assemble, and it still you can have a whole lot of fun. And you know, the only cost is going to be your engine. Maybe you need to go ahead and go buy a launch pad kit. But I just kind of looked at it. I'm like, well, should I buy this rocket kit that's going to cost me $15 or $20, or can I just make this myself? And because money is tight a lot of times, I said, let's figure out how to make this ourselves and just cannibalize the stuff that we have around the house that we can use. So here we go. Experimental rocket, yes. The only thing that I'm experimenting on is the length of my fins. I took the fins on this one and I stretched them out really long. It looks like some of those old Russian rockets from back in the day, but they're different than my normal fins on my normal rockets. This one here was also kind of an experiment. I didn't have a long tube. You'll notice this is a pretty good sized rocket right here. I mean, you see the difference in the two of them. This is your average size. This one here is long and it's a lot fatter. And so I had to look up how to wire up the motor mounts. This has got 3 engines, or yes, combustion engine. Okay, this is engines on this. And the first time we shot it off, the one and only time we shot it off, it actually did not fire all 3 engines. It went up about 10 feet and then turned sideways and went another 30 feet until it hit the ground. And so that was a kind of a dangerous situation. And I have to remind my students, stay away from the rocket until at least a minute has gone by, because we don't want that thing blowing up in your face. So that was what happened here. The nose cone on this one is actually made out of the top of a water bottle. Let's see if I can put it there where you can see it in the lighting. And I just put it right down on top of it. And it's got a little cap in there that actually goes in the end of the tube. One, not even going to be able to get it back on now that I've taken it off. But I guess I could take a cricket and maybe send it up into space. But I want to be careful about that. I don't want to take I'm not going to take a frog and send him up into space. I don't know. I feel like that's kind of cruel. Probably is for the cricket too. But the cricket would probably survive. I don't know about the frog. I don't want to be cruel to animals. So there's that rocket. This is another experimental one. I said, hey, what could we make a square rocket? Okay. And so this is made out of a box. These blinds that you see on the window behind me came in these square boxes. And so I said, this looks like it would make a good model rocket. So you can see the end of it right there, how square and long it is. And so that's how, that's just another experiment. I decided I wanted 6 fins on the bottom part. And this one is actually going to have 4 engines at the bottom. So these are experimental rockets, but I want to talk to you about making just your general everyday rocket that's going to have 1 engine. All right. So the first thing we need to do, and this is probably the part that everybody thinks is probably the most exciting part to make the rocket, and that is the fins. And so this fin that I have right here, you say, wait a minute, that doesn't look very much like a rocket fin. Well, actually it does when you fold it over. I like to make my fins where they're a little bit stronger. And so I make them so I can fold them over. And there we have it. There is our rocket fin. I'll just hold it up to the side here like this, and it would go on the side of the rocket. Something I do with the fins is once I come up with the design that I want, I design it so I can fold it over. And then at the very end of it, I put these 2 tabs on, and I'm going to bring this to the camera so you can see it. Okay, there you go. All right, so you can see that right there. Now, if you'll notice right here, okay, you notice this pin mark through here, okay, and a pin mark over here. Well, what I did is after I cut my fin out, I fold it over and I decide where I want my fin to bend at. And because this is cardboard and it's a little bit more sturdy, I take a ballpoint pen and I put a ruler down right where I want to bend it. And I take that ballpoint pen and I press it real hard on that cardboard and go back and forth about 4 or 5 times. That puts a really nice crease in it so that I can bend this little tab back. And so now I have a tab on the edge of my fin that can go right onto that can glue right onto my rocket. And it makes a good place to glue that on there. And by the way, I'm just using Elmer's glue, nothing special about it. You could use other types of glue, but Elmer's is real nice, real easy cleanup. Here's another rocket fin. You see, folded out, it looks, well, kind of like a diamond, I guess you could say, right there. And again, here's my tabs. I fold it over so it's symmetrical, and I have my tabs that fit on the side of the rocket. Now, for some of you that are a little bit more into, you know, unicorns and purple unicorns and stuff like that, and sparkles and all that. So if there's any girls out there watching, here you go. You have the heart-shaped fin, okay? And here's the heart-shaped fin. And yes, but the only problem is once you get this fin, you only have half a heart, okay? Because there it is right there, because you fold it over, and again, it attaches the same way as the other fins do. And this seems to be a really good way to attach these to the rocket. All right, let me go back over here behind the table and go to the next part. I want to just briefly show you another experimental rocket. This is another one from one of my students. He got the design idea from one that I did a couple of years ago, and we used 2 cylinders. And so we said, you know, what would happen if you have a round fin that goes all the way around? How would it fly? And so that's what he's doing. By the way, he's nicknamed this one the plunger because it looks like a plunger, okay? But anyway, let's see. Here's a rocket that you can see the colors show really well how the fins attach. Looks like this came from a graham cracker box, okay? But you see how the fins attach to the side of the rocket. Now, how do we get these fins straight? That is going to be probably, I think, the most innovative part of this. And I'm not sure exactly where I learned this. I want to say that I actually learned it on YouTube, but I'm not really sure. So what I've done is you take a tube. By the way, you need a sturdy tube. I do not like using paper towel rolls anymore because Bronny took the strength out of the tube and stuck it into their paper towels. And so now the tubes are floppy. I don't care for those. You have to get a sturdy paper tube. And once you have that paper tube, then you get a strip of paper. It can be any paper, just a scrap paper, and you wrap it around your tube. Once you wrap it around your tube, tape it off so that you have a nice little ring on the tube. And as you can see, I've done that right here. All right, once you have that ring on the tube that's fairly snug, you don't want it too loose, you don't want it too tight, but just decently snug, you can pull it off of the end of your tube. And what you will do is you will take this piece of paper here, this ring that you made, and you're going to flatten it out. So now you have a flattened out ring, and then you take that and you fold it again in half. Crease that down real good, open it back up, and everywhere that you have a crease, that's exactly where the mark is to use on your fins. And so you put it back on the end of the tube, and that's not always easy to do. Sometimes you actually have to take it apart and tape it back together. In fact, this worked beautifully the other day, and today it's not working at all. So, you know, there it is, got it to work. Okay, so let me bring this over to the camera again, and I will show you how to, let's see if it can see those. Casey, can you see the marks on here? Can you see a mark right there and a mark up here?
Yes, I can.
Okay, I'm assuming everybody else can. But what you do is you mark down here at this end of the crease and you mark up at that end of the crease. You move your sleeve up just a little bit and you to the mark right there, and then you go up here and you mark again until you get the distance of your fin figured out. Once you get about 2 or 3 inches of marks there, well, all those marks right there, that's where you're going to line your fin up. You want your fins to go straight, because if you don't, your rocket's going to go up into the air all wonky, and we don't want that. And so that's how you straighten that part out. Now, you go ahead and take, you mark all the way around. This is made for 4 fins. By the way, I did make one for 3 fins one time. It's a little bit trickier because you have to fold it into thirds. And that's not as easy. So I use a 4-fin rocket most of the time with people. And one other thing that you want to do is move the sleeve to where it's where the mark is halfway between 2 of your fins. And when you do that, go on up the fuselage about halfway and put 2 more marks. That's where your launch lug is going to go. Okay, once you have all your marks on it, you can take the sleeve off of the tube and get to work on it. And I'll explain that part. Okay. So the next part is, I have all my fins cut. What do? Well, you take those fins, get them where you want them, and line them up with those marks that you made, and you glue them on. It takes about 2 or 3 minutes to glue a fin on and hold it in place until it dries enough that you can let go. So it takes a little bit of patience, but you do that for all 4 of your fins. And once you are finished, then you come out with your fins looking something like this. Okay. The next thing I do, I like to take a little bit of glue, and I'll go ahead around the edges of where the fin is at, and I will put extra glue on that, and I will smear it on with my finger and smear it on real good. I'll let that dry. I'll put some more on, smear that on. And what we're doing is we're trying to decrease the wind resistance and to make it nice and smooth where these fins attach. Just kind of something extra I do. I don't know if I really need to do that, but it helped out a little bit. One of my students put so much glue on, I mean, that thing was slick as could be, but let me tell you, I think she added some weight to it. So I don't know how well it's going to do, but I think it'll do just fine with what we're doing. So, so anyway, that's the fins part of the rocket. Next thing I want to move on to is probably, well, I won't say it's the trickiest thing, but I want to say that the nose cone is one of the other tricky things to build on your rocket. And that's because, first of all, how do we make something cone shaped that's not originally cone shaped? Well, again, I wish I had a piece of plastic or a way to mold something and make a nice pretty nose cone like you can buy in the rocket kits, but I didn't. So I said, we've got to come up with a cheap, easy way to do this. Well, here you go. You take a piece of plastic that's round. It could be a lid off of an oatmeal container or something else in the kitchen, but just get a plastic lid and you lay it down in your paper. Hold that down real secure and draw a circle around it. And let me give you a couple of hints right here. After you draw your circle around this paper, I don't know how visible that is on the screen. Something that I like to do is I will cut this off, okay, so that I have just this that I'm dealing with. I don't want to deal with this paper. Notice also that I didn't cut this out of the middle of my paper. I cut it out of the side of the paper. Conserve your paper. You're going to need this for other things, okay? So here it is. I cut it out. And I go ahead and cut this out, cut it right on the line, as careful as you can be. Some people have a hard time cutting a straight line. Take it slow. Okay, that's the way to do it. Take it slow. And pretty soon you wind up with a circle like this. Let's see if I can hold it over here. I see there's a darker background. It's easier to see on the camera. Okay, and the question is now, how do we find the middle of a circle? Well, in geometry class, I learned how to find the middle of a circle using a compass, a drawing compass. And that's a great way to do it, but not everybody has a drawing compass laying around or wants to take that time. Here's a quick and easy way. You've got cardstock. It folds, okay? So you fold that cardstock over, fold it in half. You don't have to crease the entire thing, just crease in the middle, okay? And then you're gonna fold that in half again, where you have it in a quarter, like a quarter of a piece of pie, and you crease it again right there in the middle where that point comes to. When you open it up, you're going to find that where those 2 points come to, that is the middle of your circle, where those 2 lines cross. So you just take your pencil and you mark the middle of the circle there. And then you take your scissors and you cut straight from the side, straight to the middle of the circle. And only cut it that far. Kind of looks a little bit like Pac-Man, I guess, but not quite. He's got his mouth closed. All right, so there it is. Now, how do we make the cone? Well, so you probably figured it out by now. Now you just pull one tab over top of the other one and just twist it around and wrap that extra around the top. And guess what? You have your nose cone. Okay? You have to adjust it to the right size, and that's a little bit tricky. You have to look at it and say, no, that's a little bit too big. I want to make it smaller. So you take this and you make it a little bit smaller. Used to do something similar to this with my Sabbath school lesson when I was a little boy. And, you know, we would roll those things up, and I learned how to tighten a roll up. Yeah, that's about right there. And so what I do then is I take a little bit of Scotch tape and I tape it off. And once it is taped off, another problem with Scotch tape. All right, let's try this one more time. There we go. Okay, now I've got it taped off and it's holding just fine. Now, sometimes it might be just a little bit crooked, so just take your scissors, trim off that bottom part, and you're good to go. But now we have another problem. How are we going to attach this nose cone to the rocket? We need a way to attach that. And so what I did is I have come up with another way to do this, because it's, if you find two tubes that one fits exactly inside the other, keep them, use them. Don't let anybody else have them. Okay, keep that one, because they're real useful for making rockets. But I don't always have that, so it's like, well, what do I do? Well, you notice how this one's black? Okay, this is a black ring that I made right here. This rocket right here, one of these black tubes, that's what I used to make the ring with. The problem is that tube is almost identical to this other tube in my hand, and I have to find something that is going to fit inside of it. And so what I do is I cut about an inch ring off of that tube. And by the way, what I'm using to cut this with is just a utility knife, razor knife. Now again, for a disclaimer here, do this under adult supervision, but be very careful. I promise you, you will cut yourself once and be more careful after that. Don't cut yourself the first time. All right, so here we go. I cut this tube off. I got about an inch of it. It may not be exactly straight. It may not be pretty, but it doesn't matter. Nobody's going to see it anyway. And then I take the pair of scissors and I make a slice in that ring so that it comes apart. Okay, if you can see it there, it's almost like a C. It comes apart, and I take that ring that is now apart, and sometimes I have to trim parts off of it. And so I'll come back with the scissors and I'll cut a little bit more off, and I'll cut a little bit more off. And finally, I get it to where this ring, in fact, let's see if this one will go in here. I don't think this one's going to go in. Oh yeah, it is. Okay. I get it to where it goes just inside my tube. When I get it there, it is perfect. And so what I do is I take another piece of tape, okay? And once I get it right where I want it, then I just take that piece of tape and tape over that little area where I cut it. I can pull it out, and then I can wrap more tape around it. You can't wrap too much tape, because if you wrap too much tape, it's not going to fit. So put a little bit of tape around it, what you need, but don't go any extra. All right, then I'll take this ring right here, and I'm going to glue it into my nose cone. Now, there's a problem. Can you see the problem in the nose cone that I have right here? Casey, can you see the problem with that? What's wrong with it?
It's not straight.
It's not straight. It's all wonky, right? That's our word for the day, is wonky. We don't want wonky. So you have to straighten it up. Once you get it straight, you look at it, you say, okay, what do I do? Well, take a little bit of glue, go around the inside of your nose cone, take your tube, your cup link, I like to call it, put it inside there, get it straight, hold it for a couple of minutes, and then later after it dries, put some more glue on it just to make sure it's nice and secure. And pretty soon you have a nose cone. And that's the nose cone that I painted up there, but that one works very well on this rocket. Okay. Next part of the rocket is the motor mount. This is probably one of the ugliest parts of the rocket, and it's probably one of the trickiest parts of the rocket. But to be honest, it's probably one of the most important, because you have to have that motor in place, or that engine, the engine mount. You have to have the engine in place so that it does not shoot up through the rest of the rocket. because what will happen is the engine shoots through the rocket, blows up on the launch pad, and then everybody goes, wow, and laughs at it, which still is kind of funny, but we don't always want that to happen. So here's what we're going to do. We're going to make an engine mount. Now, let me bring this over to the camera so you can get a good look at it right now. Okay, and essentially what you have, let's see if I can take this engine out. This one is made just a little bit messed up. All right, there's the engine. Oops. All right, you've taken cardstock or an index card, you've rolled it around a tube. You have made 2 rings, which are not glued down at the moment, but they will be later. And you've made it like a washer, a donut washer, so to speak. I just call it a donut, these donut rings. And then on this part right here, we have another piece of metal, which I'm going to explain here in just a minute. Let me show you how to put all of these together, and I will give a little bit more thorough explanation of this. Okay, so I needed to get something the same size as my tube, but I needed the inside diameter of my tube. So I said, well, what can I do? Well, it just so happens that one of my teachers that I teach with, she teaches in the next room over, had an ink pad, okay? And the ink pad worked out really great because then I needed the inside diameter of this tube. I put my tube down on the ink pad, I put it over here on the paper, put it straight down, and I had a tube. I don't know if you can see that there, maybe, kind of. Anyway, the ink gave me a nice little ring on the inside of that. And so then I go to cut it out. Now, this is the tricky part about cutting out these little donut rings, okay? First of all, once you get your ring size figured out, then you have to figure out, okay, how big of a hole do I put in the middle of it, and how am I going to do that with this big old pair of scissors? Well, a couple of things that you can do. First of all, you know that your engine mount, the tube part of it, is going to be just barely bigger than the outside of your engine because it's made out of some cardstock and you're going around the outside of it. And so I found something that works really well. It's right here. Everybody's seen these whiteboard markers. Whiteboard markers, it turns out, are just barely bigger than your engine, which is perfect. Now, this is for an A, B, or C size engine. Okay, I'm not going into D's right now. If you're going to shoot a D engine off, good luck with that. You know, you'll find some other way to make this. But here's the basics. All right, it's just barely bigger than my engine. So after I cut my initial circle out of the paper, I need to get the inside circle. So I take my Expo marker and I put it right down on top of that. And then I take my really sharp pen or pencil and I go around that and I have the perfect size for my engine mount, for the tube part of the engine mount. It's a little bit tight, but it works out pretty good. And so I've cut the outside out. Well, what do I do with the next part? Well, here's the tricky part. And here you think, oh no, I'm going to ruin it. No, actually, you're not. Okay. What you do is go ahead and cut from the outside of the circle, cut to the inside of that circle. Once you cut around the inside of the circle, you're going to have a circle that's shaped like this, but it's broken in the middle. Well, that's where the wonders of Scotch tape comes in, and you can take that circle and tape it back together. You've cut out the middle part, you've cut out the donut hole, so to speak. And so now I've just put it back together, cut that tape off the side so it's out of my way, and I have a donut ring. Again, later, if you need to see this, just go to my YouTube video and you can see that, and it works out really good. So you're going to need 2 of these, okay? And the next, what I really like to use, and this one has kind of already been cut on, but an index card. Index cards tend to be exactly the right size for these A, B, and C engines because of the length or the width of the index card. So you're going to take your index card, you're going to wrap it around your engine, and once you get it around, you're going to cut that off. Cut that off, wrap it up real tight again around the engine. Take your, let's see, you have it rolled up, okay, and I'm just doing a quick demonstration here. You have it rolled up. Once it is rolled up, you tape that off, and you have your engine. I don't know, it's the part that holds the engine. I don't know what you'd call that, but the cylinder comes out just like this. And so then you can take, well, actually, you don't want to take the rings yet and put them on because there's one more part. And I must have done the video with this one. And so I'm going to need to cut this apart here, and I'm going to show it to you up close on the camera because this is an important part. Okay. You can use any type of stiff wire. Let's see if I can get it right there. Yeah, there we go. Any type of stiff wire will work, but I bet you'll never guess what this comes from. Casey might. Okay, this actually comes from my windshield wipers on my car. And when it's time to change the windshield wipers and I put new blades on, I take the rubber part off, and there's these little flat, thin pieces of metal in there. And I take those flat pieces of metal and I bend them into the clip that holds the engine in place on the side of the rocket. And so the way I do this is I have to put it up to my engine. Okay, let's see if I can show it right there. And I'll put a bend up here. Okay, that keeps the engine from shooting up into the rocket. And then I put a bend down here at the other end of the engine. That keeps it from falling out. And I do this, just do a little S curve right here. That way later on I can go and pull that wire up and pull the engine out and then let it back down or replace it with a new engine. All right, so that's how I do those right there. Again, just tell your dad or mom, say, hey, mom, dad, don't you think it's time we change the blades on our windshield wipers on our car? They're like, what are you talking about? Well, this is what I use for this. You can use a paper clip, a good stiff paper clip. You can use some other wires, but this is the one that works the best for me. Once you have it in place, I like to go ahead and use my engine just as a guide because it needs to stick out of the end of the tube about 1/4 of an inch. Then what you do is you take that little wire piece I showed you and you put it on the side of this and you put it up here where the top of the engine, where it goes to on the tube, okay? Now this tube is just a little bit long. Usually my tubes are a little bit shorter, but you put it where you cut in the side of it. You can either push it through or maybe just use a razor knife and cut it through. Put a little hole in the side of it so you can stick that wire mount in there, wire clip, I mean, and then there it is. I have the engine sticking out, I have the clip on, and the only thing I need to do is tape it down.
Can you show that to us closer?
Oh, okay. All right, I'm knocking things down here. Okay, so here we go. So you can see I've got it where it can lift up and I can pull the engine out. Again, this one, I think I would have it stick out just a little bit further, and I didn't do that on this one because this was just a demonstration model. But there's the engine inside of the tube. Here's the clip, and the next thing to put on is the rings. So you put those rings on, slide them down towards the end of the engine. You want it about 1 inch from both ends, approximately. That's a good place for it. And you look at it and you say, wow, that looks like it's not that sturdy. It's not that sturdy yet. But you're going to take Elmer's glue and make this thing really sturdy. So get a little bead of Elmer's glue, put it around here, put it around this other side, do that on both of these parts, and give it some time to dry. After it dries, if you think you need some more, put some more on. Don't put it all the way down there at the end. You want to push this back about an inch. Then the next part that comes along, when we actually mount it into the tube. Now these are not exactly fitting for this particular tube, okay? So I want to explain something to you. Just because they're not fitting doesn't mean that this isn't something you can do. Go ahead and push that down in there. Oh, I'm sorry. Put a little bit of glue on the inside of your tube. Push your motor mount down into your tube. Put some more glue on it. And you got to hold it straight. This one's not going to stay straight because it's not a stiff one. It's just a demo model. Put some more glue in here. And then you're going to push this down again. Push this inside here. And you want it to stick out where the end of it is just almost flush with the bottom, or right at being flush. That is a good place to have it. It's okay if the engine itself sticks out just a little further, but right about there is where you want your engine mounted. Anyway, you put some more glue in there, and then I like to set mine up like this and let it dry overnight. Now, I will tell you, if you put too much glue, what's going to happen is a bead of that glue is going to run down to the other end of the rocket. So be careful how much glue you put in this at first. After it dries overnight, put some more glue in there and make it nice and stiff. Let me show you one that I did the other day. Well, here's one. Let's see if you can see in there. That white in there obviously is white paper, but it's glue. Okay, and that's what it's going to look like. Here's another one. This is the 4-engine mount. I don't know how well you can see that, but yeah, right in there, that's glue on top of that paper, right inside there in between those engines where they go. And so once that's done and dry, you're ready to go. I mean, as far as going on to the next part of the rocket. Now, let me explain something else. Remember I told you earlier about putting launch lugs? A launch lug is basically a plastic straw. Now this one I have taped them onto because I never had time to glue it. But you can put you a little bead of glue on there, put the straw down, put a little tape over it, and I would just use Scotch tape. This is masking tape here, painter's tape. But just some tape to hold it on because Elmer's glue does not like to stick to plastic. And so that becomes a little bit of a problem. Once it is secure, pull your tape off and then go back to glue the straw down, put some extra glue on it and go around it so it holds it on. The only thing the launch lug is there for is to hold the rocket straight while it's on the launch pad. Once it shoots off, there's no use for it. But it is definitely something that you have to have to hold the rocket up. Okay, so we have.
And on that note,
Yes.
Most model rockets have 2 launch lugs. It just gives it a better chance of flying straight, if I'm correct.
You know, it could go either way. It depends on the length of your rocket. This one here, I messed up on. I've got a launch lug down here and I've got one up here, but my nose cone hangs over just a little bit. And so it's actually going to hold the wire a little too close to my nose cone. So I may have to do some modifications here and fix that. Most of them, if you put it about the center, it's fine for the shorter ones. Now, if you have a longer one, like something like this, or I'll show you one right here. Okay, this is my really long one, and had fun making this one and watching it shoot off. But this one, I actually have 3 of them on. I don't think I need 3. I think it was almost an overkill. And it was just about taller than the little wire was on the launch pad. So had to be careful about that. But you can also look down your, like a gun sight, kind of look down the launch lugs and make sure that they're lined up if you are using more than one. Okay, we're going to come back to this rocket here in just a minute because the last thing I have to talk about is the recovery device. And as Casey was saying, for this honor, part of the agreement was that you are going to use only a parachute or streamer recovery device. And I want to tell you the difference between the two. A parachute looks cool. Okay, it really looks nice. I like the parachutes. The only problem is out here where I have to shoot the rockets off, if there's any breeze, it could literally take my parachuted rocket, it could literally take it over into Highway 40 because we're just across the road from Highway 40 and we don't want that to happen. So I needed to come up with a way to make the rocket come down faster, but yet not come down too fast to where it was going to hurt something and minimize the drift. So my preference, other than a parachute, is to use streamers. And here's a couple of streamers that I made. These are homemade streamers. Want to take a guess, Casey, on what it's made out of?
Trash bags.
Exactly, trash bag. Again, something. What?
Trash bags which are not flammable. So.
Well, yes, that's true. They're meltable, though. In fact, that's very important. When you pack the parachute or the launch pad in, make sure that you put in recovery wadding. Okay, it usually comes with your rocket engines when you buy it. But recovery wadding is a fire retardant paper and helps keep your parachute or streamers from getting melted or burnt. It's definitely something very important. Okay, so anyway, I cut a couple of strips out of a black plastic trash bag. They're not pretty, okay? But it doesn't matter. I need to create drag, but yet I have to let my rocket fall fast. And so this is what does it. So I've taken the streamer, I've tied a knot in the middle. Actually, I tied a knot using my rubber band in the middle here. And that's what I'm going to use for my recovery device. Now, we'll talk a little bit more about that part in a minute, but I want to talk about how do we attach this to the rocket. And what I've used, I've got some rubber bands. Let's see if I can get a darker color. Might be able to see that a little better. Okay, big rubber bands. You can use elastic that you can find down at the sewing section at Walmart, but I've just used some rubber bands. And so what I did is I cut that rubber band into where it was one long strip, okay? And I took that strip and I tied it around here in the middle, tied it around my trash bag and pulled the knot fairly tight. And it was just a single overhand knot, nothing major there, nothing special, just a knot to hold it. Then on the ends of the rubber band, what you're going to do is you're going to take a piece of paper, okay, just a strip of paper. It could be the cardstock that I showed you earlier that you might have left over from making your engine mount, or it could be, you know, whatever. This is construction paper right here. And so I fold this construction paper, this paper over to where it's got about 2 or 3 bends in it. Then I take it and I lay my rubber band on that, fold one side over, fold the rubber band back, and then fold the other side over to where it's nicely caught in there. Let me go ahead and show that to you on camera up close. See how this rubber band is caught inside of here? Okay, and all I've done is I've laid it in here. I put one side over the other, fold the rubber band up, put the other side over, and then I have to find a way to secure it. Okay, and so what I do to secure this is 2 things. First of all, Elmer's glue works great, but in order to make it stay there, I'll just give it 1 or 2 staples. There you go. Staples work great. Okay, so we just stapled it. And the next thing that I do is I want to put it on the inside of my rocket. And so I'll take this, I'm going to put some glue on it, and I put it on the inside of the fuselage of the rocket about 2 inches down, probably about, from end of your finger to the knuckle. It's about 2 inches down. I glue that in there, hold it for a few minutes till it stays, and then I let it dry. I do this. Okay, now remember this is connected to the we call it the streamers or the parachute. I glue that in there, and then I take the other part and I glue to my nose cone. Now, I have different nose cones. This one, of course, is for the square rocket, but this one here, I would just stick it right up inside that cuff link and just glue it up in there. All right. And then once it is all dried and everything, then it's time to fold it up and put it inside. I take my recovery wadding and I stick that down into the rocket first. And once it is stuck in there, then I take the streamers and I roll them up. Okay, you can actually fold them over a couple of times to make it a little faster. But you're going to roll them up in a very tight roll. Now, if you are using a parachute, do not make it too tight. Parachutes have extra strings on them. And if you roll it up too tight, you will, when your parachute pops out, it will never deploy. It'll just stay in a wad. You don't want to do that. With streamers, you don't usually have that problem. You just roll them up. You roll them up, you stick them inside the rocket, and once they are in the rocket, it is ready to go. You have your recovery wadding on the inside here. You have your engine mount, and with the engine on it down at the very end, so you're ready to shoot it off. Let's see if this recovery device will work for this particular rocket. You guys ready? Say yes. Okay. Oh, it didn't work. Well, what's the matter? Well, I probably had it rolled up too tight. Let me try it again. Something in here did not want to come out. Oh my. Maybe I pushed it too far down in. I'm not sure. Wow, when I did this on my video, it worked great. But of course, it's not going to work right now. No, not when I'm live. Not when I could be embarrassed because of this. There it is. All right. I'm not sure what went wrong with that one. Let's try it one more time. And if it doesn't work this time, I'm going to say this is just how you're going to do it. You're just going to have to experiment, though, to make sure everything comes out. Okay. Let's try this one more time, see if I can get it to pop out of there the way it's supposed to. All right, there you go. It worked. Okay, so the recovery device comes out. Again, experiment with how to roll this up because it makes a difference on how you roll up, how well it's going to come out. So it's ready. Now, just a FYI, if the recovery device doesn't deploy or if your rocket's fairly heavy and it doesn't slow it down too much, I've actually had these rockets come back down to the ground and stick tail up right into the dirt. It was hilarious. In fact, if I can find those videos, I will post them on my channel also, and you can just go to the same channel that you found the make video on for this. You can go onto that channel and you can find some other videos if I can find them. I have to look for them. And but that is the main part of making the rocket. The other part is, of course, your launch pad. And I would suggest go ahead and spend the money, buy yourself a launch pad, unless you are a DIY person like myself and have access to all the materials to make a launch pad. But one of the things that Casey said earlier, it is very important that you have a deflector disc that is made out of good metal, because I made one out of one of those, those aluminum cookie sheets one time. The rocket engine burned a hole in it immediately, burned the grass underneath. Not a good idea, okay? So, so it was a bad idea. But yeah, use a deflector disc that works for the rocket engine that you're using. Casey, do you have any questions or anything you want me to go over again or that I forgot to cover?
I do not have any questions. I just wanted to ask and see if Donato had any questions. Donato, you're welcome to put it in the chat box or even turn on your mic.
No
Okay,
questions.
so no questions. Then I am going to play a short video just so you can see a rocket launch, which living in Florida, you've probably seen lots of NASA ones. But just so you can see what a model rocket launch looks like. So if you'll give me a second, I'll share my screen. Dad, can you go ahead and mute yourself, please?
Yes.
Where?
Okay, Casey, after you're done, I do have something else I want to say about the rockets.
Okay. Oops. I am just trying to find the right screen to share it in. All right, and let me know if the volume comes through or not.
Okay, hook it up. All right, I'm gonna stand right here. 5, 4, 3, 2, 1. Hold it down. Yeah, we have a shoot. Good shoot. A good shoot. Shoot.
All right, so that was the rocket launch. And Dad, you said you had one more thing to say.
I do. Can you hear me okay right now?
Yes.
Okay. One of the things that I was meant to talk about while I was giving the demonstration was, and it goes along the spiritual side of this. There's a lot of parts to these rockets, and this is very simple. I mean, we have paper, glue, a clip, a plastic straw, and a cardboard tube, and some cardboard that we use for the fins. Oh, by the way, just one quick side note. You can have fun painting these, as you can see I have. I like to paint a base coat, like this one. I painted the silver on the base, and then I put tape on it where I did not want the color to be, and I painted the other colors, and then pulled the tape off. So that's how that one was done. But no, what I really wanted to talk about, just real quick, on a spiritual side, there's a lot of parts that go into making one of these rockets. But yet, reality-wise, it's only a list of things that you can list off on basically 2 hands, pretty much. And I mean, tape, glue, cardboard, plastic, and wire. And that's it. And now, let me ask you this. Would it be possible, do you think we could take all these different parts and even if they're cut out correctly, if they were cut out correctly by some unseen hand, take all of these different parts, stick them into a dryer, and so it could go around and round and round and round, and then in 10 years, come out with a working model rocket? Well, no, you say, that's absurd. We couldn't do that. Well, that's what the world is wanting us to believe about evolution. And the world wants us to believe that all of these intricate parts to your body, in which it's much, much more complex than our bodies. They want to say, yes, all of this happened because of some great cosmic accident 14 billion years ago. And over those 14 billion years, all of these parts came together just right, just at the right time. And we now have mankind living on this planet. Well, you can see the logic in that. It's just absolutely absurd. And so the Bible says, Genesis 1:1 says the first 4 words, it says, in the beginning, God. And that's it. The Bible never questions the existence of God. It always assumes it. And if you look on down in the days of creation, you'll see that it says, and God created the cattle of the field or the beasts of the field or whatever, and they would produce according to their kind. And then the apples on the trees or the herbs of the field or whatever, the plants produced according to its kind. Right there, at the very first chapter of the Bible, is God's answer to evolution, according to its kind. And so one thing did not evolve into another. It's like taking all these complex parts and actually simple parts to a rocket and saying, oh, I can tumble this around for 10 or 15 or 100 years and come out with a working rocket. Well, the reality is, no, you can't. You would wind up with a mess. And, but yet the world is wanting us to believe that. So just another spiritual lesson from the rocket. I mean, this rocket had to have a designer, okay? There's no way that it came out on its own like this. And so therefore, I also believe that we have a designer, and that designer knows the best thing for us in our lives.
All right, well, thank you for coming. I'm going to close this out with a word of prayer, and then you guys are free to go. Dear Heavenly Father, thank you for this chance to make something which I know my dad and I and a lot of other people find a lot of fun, and for the reminder of just how great you are, because you gave us an intelligence to learn more about you, to learn more about the world around us, which is absolutely astounding and shows just how much, or just one way that you love us so much. And so we thank you for that. Please be with the Pathfinders throughout the rest of this camporee as they get the chance to have fun and learn more about you and just how much you love us to the extreme that you sent your son to die for us. So we thank you for everything. Amen. All right, so I hope to see you at the next event, hopefully in person, but if not, I look forward to seeing you in heaven. So, bye.
And Donato, make sure if you can contact Casey later and show her what you did with the rocket. I would love to see that and see maybe a video of it or something. So anyway, God bless you and anybody else that's watching us. Freeze frame. All right. Well, Casey, I'm going to go ahead and get off of here.
All right, yeah, I'll call you after.
Okay, we'll talk to you then.